All right, so let's go ahead and begin. Um, First, we'll let you know that this introductory section is going to be recorded, and the breakout rooms will not be, but this intro section will be. So I just want to give you that little disclaimer. So my name is Brian Campbell, and I'm the Trees Around the Globe Student Research Campaign lead, and I'm going to talk quickly this intro about the campaign, some overarching things and concepts about it, and then if you care to join the breakout session on the campaign, we'll dive a little deeper into it, show you some things on the website. So next slide, please. Oh, next slide, and you can throw up the polls. There's a couple quick polls here that are going to be put up, just simple questions. Here's our core campaign team. And you can see it, myself, Dorian Janney, Peter Nelson, Dr. Christopher Schumann, and Peter Falcon. You probably know all of them if you've been to the campaign webinars. You've seen us all on there. And if you could throw up the polls.
They're going, Brian.
All right. I just didn't see them on my end. So let's go ahead and go to the next slide.
Yeah, we've got a decent chunk of votes on there.
Okay,
so.
Great. All right, so a little bit about the campaign. Next. All right, so what we're doing this year, we're in year 3 of the campaign, and we've created a scaffold structure where it's broken into quarters. The first one is we're front loading the science involved with the campaign, from tree heights to land cover to carbon cycle to greenings with green up and green down. And then the second quarter, from December through February, we're going to be focusing on taking that science and helping students plan research projects using that science that they've learned and that the educators have learned at the webinars during that first part of the campaign. Following that, we're going to be going over what was submitted in relation to the campaigns to student research themes, like for IVSS, the US SRS and things like that, and even local or virtual science fairs. So we're going to be focusing on that and have some more student presentations. And then finishing up year 3 of the campaign, we are going to have a 1 to 2 day thematic workshop. We will bring in students, educators, researchers, citizen scientists to talk about 3 years of the campaign and what has been done, what has changed throughout this whole pandemic versus what was done before, how everyone has looked at the data, how much data has come in. So it's going to be a really cool workshop that brings together 3 years of the campaign with this scaffold structure. Next, please. One thing that we're really focusing on for the campaign this year is, since we're looking at data specifically, and that's what the NARM is all about, data literacy, we're focusing on a thematic overarching research question called a TORC. Why are or why aren't there trees in my local environment? In order to answer that question, we provided a bunch of example exploratory questions, just smaller questions that can be explored to help answer this larger research question. And this all lends itself into what the next step is for the students and developing research projects. How can you answer this larger question by exploring these smaller questions in the research that they're doing out in the field, or they're doing, looking online at online tools, or just looking at the globe data and doing some analysis of it. Next. And just a couple facts here, why tree height is so important and why does NATS and the GLOBE program care? My favorite one I like to say is tree height is the most widely used indicator of an ecosystem's ability to grow trees, and tree height allows you to track the growth of trees over time. The tree height observations help researchers at NASA and beyond to understand the gain and loss of biomass, which can inform calculations of the whole carbon cycle, what trees are taking in, what trees are storing, okay? And then there are NASA missions out there like ICESat-2, the Ice Cloud and Land Elevation Satellite 2, and the JEDI, the Global Ecosystem Dynamics Investigation, an instrument on the ISS, International Space Station, which uses LiDAR, onboard laser altimeter systems, to measure the height of forests and forest canopies globally. Next, please. And one thing we like to reinforce, and I know some of my colleagues might do this as well, with the campaign, what we always recommend is that when you're out taking like a tree height observation and you're in that same location, look around and take a land cover observation. Look up, take a cloud observation, and then look to see if there's any potential mosquito habitats. When you have multiple measurements in the same location at the same time, it really helps to paint a picture of that local environment and helps us understand that larger picture of how our planet's changing over time. And I believe that was my last slide.
Hey, thank you, Brian, because that is also one thing that I'm really interested in, is seeing how all the data, when they're collected at the same time, how they can be analyzed by our citizen science group. So hi, I'm Rusty Lowe. I'm with the Globe Mission Mosquito Campaign. And what I wanted to do now is just show you some of the things that we can talk about in the breakout group. So if we go to the next slide, I'll just show you that this is what we are doing. We are looking at mosquitoes, and they are the immature, non-biting mosquitoes, so they're perfectly safe for anyone to take a look at. As a Globe Mission Mosquito scientist, you are going to be tracking the range and spread of these mosquitoes. You're looking not only at the mosquitoes, but the tree habitats where they're living and the land cover habitats that they're living and what the weather is like when you have mosquitoes. So you can see that mosquitoes are a great way to do the Earth system. Everything is connected to everything else. Looking at the next slide, I'm just going to show you, you can do this with different kinds of resources. All you need to do this is to have the app. But if you want to take a look at mosquitoes up close and personal, you're going to need to get some kind of magnifying device. Next one. What I wanted to show you is what we've already done. We have a lot of places where we have data collected. And don't worry about looking at this list of questions, but what we can do in our breakout is talk a little bit more about the kinds of research questions that can be addressed using this data. Right now we have about 28,000 data points so far. In the next slide, you can see that what we are doing is just showing that all this, oh, I love that. How did you do that? The data is, can be downloaded and then graphed, and you can compare where you are across time. You can compare with other sites. You can compare the different habitats. You can compare the different kinds of mosquitoes. There are lots of really rich questions that can be asked. And in the next slide, I just wanted to point out that there are resources already available to you where we can look at the mosquito bundle, which shows you how you can connect your mosquito observations with protocols from all the other spheres, as well as all the other Globe Observer protocols. Finally, and this is just what Brian just mentioned, is that when you look at Globe Observer data, it's great if you can collect coincident data at the same place at the same time using more tools, because that's going to give you a very rich data set and get around some of the limitations that a very new citizen science program has with respect to temporal or spatial density. So that's one of the take homes I hope you get today from our presentations. So lastly, on the next slide, oh, okay, there we go. I just talked about that slide. Next slide, please. I just wanted to show you here that here is an example of how this data is important. We collect mosquito habitat mapper data. We found the place where the habitat where we found the mosquitoes. We can locate that mosquito and that land cover in space using satellite data. And so this gives you an example of why it's so important to connect that with land cover and other protocols. All right, fine. I think we're done here. Next one, please. Okay, just go to this one and the next one. We're just what we can do in our breakout. If you're interested, we had some great high school presentations this year, research that was done, and some of these research projects also looked at helping citizen scientists by developing computer code. So we have lots and lots of research opportunities available to students that are interested in working with the mosquito habitat mapper for IBSS or other projects. Okay. Next one, please. Okay, got some resources. We'll talk about those. Next one, please. And we've got some videos too. Okay, I think that's my 5 minutes. So thank you so much.
Thanks, Rusty. All right, so I'm Kevin Sikowski from the University of Toledo, and I head up the Urban Heat Down campaign. I do want to highlight that Janet Struhl helps me out a lot here, and then this is also part of the Globe Mission Earth project, and those are our partners there in the Globe Mission Earth project. Next slide. So on the Globe website, this is what it looks like. There's a video from NASA. You can look at why are urban heat downs important. We go to the next slide. And of course, this is the basic urban heat down figure. You know what I've realized over the last few years, we started doing the surface temperature 15 years ago, and urban heat down started to become a focus maybe about 6 or 7 years ago. But the urban heat down has become a more hot topic. But anyway, becoming more important year after year. As areas of the globe warm up, cities are growing, at least they had been, and people in the cities are more vulnerable to heat-related issues as we have a warmer climate, and the centers of the cities are warmer than the rural areas, and so the people in those cities are vulnerable to the heat. Next slide. Now, relating this to student projects, this slide here is from the NASA Langley story map on urban heat down, and it's a great resource if you want to look at it. But the idea that different cover types have different temperatures depending on the material that the cover is made out of. And so in this case, we have 19 degrees Celsius for the asphalt. The concrete is 15 degrees Celsius, so it's cooler, and that's due to albedo. But then the grass is even cooler yet at 16 degrees Celsius, and that has to do with the structure of the grass. And then lastly, in the shade, it's even cooler. So we want to study these things. So students could study a very simple question. How is the grass a different temperature than the asphalt or the concrete? Or how is the shade different than the sunlight? Next slide. And so we're doing this in October, December, and March. You can do cloud observations, air temperature, and surface temperature. It's kind of a nice combination. One thing I wanted to mention was to leave your infrared thermometer outside for an hour before you do this. If the temperature outside is much different than the temperature inside, that helps the infrared thermometer to equilibrate. And I find interesting with everybody does their temperature with the infrared thermometers now for COVID, and that they do read incorrectly, especially if you hold it in your hand for a long period of time. Next slide. All right, we can skip through these. This is like what I can talk about in the breakout room, how to do the observations. Keep going. Don't do that. Yep. Okay, keep going. Clouds. All right, I did want to mention this. This is the surface temperature sites for the last 5 years on the Globe website. You see a nice distribution across the world. Getting more in countries that haven't participated in the past, but always looking for new places in the United States. Next slide. But this is the sites we have so far this year in October. It has been limited. I think we have 60 sites there to mention, shows up. In the United States, especially, if you can't go outside, then this is a problem for doing this campaign. Also, we noticed that students don't have the infrared thermometers, so distributing them is problematic. So if you can, participate. If you can't, we'll just wait. All right, next slide. I did want to mention that Brian and I had talked about connecting the trees campaign with the urban heat down campaign. Here I am in my backyard with our I think it's a black spruce tree. How does shade affect the urban heat down? And then how are trees in your neighborhood contributing or not contributing to the heat or the coolness of your neighborhood? Next slide. And this is the story map I mentioned from NASA Langley. And see the last slide, our contact information. So if you want to come to the breakout room, please do.
So I'm Angie Rizzi. I work with Margaret Pippin at NASA Langley, and I want to emphasize that the air quality campaign is all new this year. So we all know in the past people had to use calatus or sun photometers, and obviously we are not even on center to be able to loan those instruments out. So some have them and some don't, but we have a new approach this year. We also, if you notice here on the slide, have an actual email just for the air quality campaign. So you can always contact us there or individually. Next slide, please. So the basic idea that we have for the air quality campaign is that, you know, clouds tell us a lot about air quality. We're already looking at sky color and clarity, and we even obscurations. So we've come up with some ideas and even a sample file of looking in the Viz tool. When you pull up cloud cover, if you see a black circle, that's saying that it's obscured. You can look at pictures. You can lay on the AOD MODIS base map all in Viz. You can just integrate even more data like Aerosol Watch or AeroNet and tell a whole story. So next photo, please. Next slide, please. Here's an example of one of our interns who lives in New York City and actually was taking pictures daily outside their window. If you can, and also pulling purple air data from a website which gives PM 2.5. Next slide. So you can see that the images daily are different, and then if they're able to look at PM 2.5, they can start to make some correlations with their cloud observations and excuse me, some data from another source. So that's a simple thing that some people can do. Next slide. Here is just, I'm just going to quickly go through a few slides where here's an example of some obscured cloud observations in the Viz tool. And if you go to the next slide, you can see that sort of in that same location, they had obscurations for a few days in a row. Next slide. This is kind of how they can build a story out. This particular person actually did have a calatus instrument, and so there was an aerosol measurement in the globe system. If you happen to come across that or you happen to have a calatus, you're welcome to still use it. The next slide. And those data are available also in the visualization tool for the aerosols. Next. This is showing the Viz tool with those same observations and the AOD base map turned on. Next slide. And then here's Aerosol Watch information. And in Aerosol Watch, you can have true color images. You can put on a smoke and dust mask. Next slide. You can also pull up fires and see where the fires are. So those would be the little yellow dots. Next slide. And here's just the clouds. So you can see how the weather systems might impact the movement of smoke across the country. Next slide. This we can go over in the breakout room and the next slide, but we sort of have what each of the different data sources can provide, including GlobeViz in the next slide. So what we have coming this year to support the campaign, especially since it's a little bit of a new approach, is a webinar series. So we're looking to do one on the GlobeViz, one on Aerosol Watch, one on Purple Air and the EPA Fire and Smoke Map, one on AeroNet, one on High Split, and one on putting it all together. and we'll be updating our blog more frequently and having some office hours. And hopefully we'll see you in the breakout room.